September the 1st, 1859. English astronomer Richard Carrington draws images of sunspots projected through a telescope at his home in the English village of Redhill.
All around the world back then, people were watching the surface of the sun. And every day, Carrington would sit down in his observatory, which was a telescope he had in his house, and he would look at the sun and project the sun down, and he'd make a sketch of this active region. By cosmic coincidence, as he was sitting there making a sketch one day, one of the largest solar flares on record occurred. Carrington was actually able to see bright pricks of light appear on his sketch pad because the flare was so intense and visible light that actually caused bright points to appear on the solar surface.
Carrington's drawing records the largest flare ever known. From that day to this, it's the first indication for scientists that storms on the sun can devastate our technology on Earth.
What's amazing is then what follows. About 18 hours later, all hell breaks loose on Earth. Telegraph lines start sparking and catching on fire. Compasses start wiggling around.
It was enormous. It was so big, it made what we call a geomagnetic storm, which is one of these storms where it deforms Earth's magnetic field and puts all of this energy into the radiation belts.
The aurora borealis, the northern lights, are seen all the way down to Cuba.
Places of the world where people had never seen aurora before. Places like Australia, Great Britain, and even Florida could have seen the aurora.
The geomagnetic storm that spreads chaos across the globe is now known by scientists as the Carrington event. In 1859, the newly invented telegraph machine is the only method of long-distance communication. Electromagnetic particles bombarding Earth from the huge solar flare have serious consequences, wrecking communications.
So in 1859, the loss of the telegraph system for 4 days, that doesn't seem that significant when we think about that today. But if you imagine the loss of all electronic communication, all power grids for days, weeks, months, it is a huge, huge impact on life and society.
Some estimates say that if it were to happen today, if we didn't have enough advanced warning to power down our power grids, you could lose all the transformers on the east and west coast of the United States. It could take years, maybe even decades, to restore power to the coasts.
Imagine losing the internet now. National panic would ensue.
You lose GPS potentially. A lot of us depend on GPS for things like logistics. Most major cities in the world only have enough food for about 12 hours. So if you don't have a logistics network operating, you can't supply all the people in the city. When a hurricane strikes, if there's an earthquake, what do? People leave the city, they take refuge in another city nearby. You don't necessarily have that option if we have a Earth-level Carrington event. If you lose the entire seaboard, there's nowhere to go to recover.
No one knows when a Carrington-level event will happen again. It could happen right now.
So imagine now, if we had one of those major events, it would be pretty bad. So we need to mitigate the effects of this.
Mitigating the effects requires earlier warnings of solar bombardments. For that, we need scientific data we can only get by going to the sun.